Good morning.
Good morning. Okay, good morning, everybody. So let's start. Today, the program is finished chapter 2, so now you don't have any stress about doing labs 1 or 2. You have everything. And yeah, hopefully we start a bit chapter 3. So yeah, chapter 2 is still a sort of introduction to the material, and chapter 3, we really start with microeconomics, new stuff, important stuff.
Professor?
Yes?
We're doing 1.3, correct?
Yeah, I think I was there. The graphing economic data. Yeah, we just finished there last time. I don't know what number it is. It doesn't matter. So here we are in the material. All right. So just to remind a bit everybody what we were talking about last time. So we were talking about theories, and then we briefly finished with yeah. So how we test our theories, and one big tool, of course, is first of all is we use statistics because what a theory is oftentimes is you're claiming that there's some link between some variables, say x and y. So x is sunlight and y is temperature. So for instance, or x is age and y is height, for instance. So and one way to do that, yeah, so of course, so correlation versus causation. So as we've said, one does not imply the other. Two things could look correlated, but one, you don't know whether x causes y causes x, or some other variable causes the two others, or whether that's just fortuitous. Yeah, so for instance, in this case, it looks like there is some inverse correlation, because when steel goes up, newsprint goes down, and vice versa. Does that mean anything? Who knows? Maybe it's just an accident and it's going to change. But if it never changes, then maybe there's yeah, it looks spurious because we have to use our judgment for it. But yeah. All right. So here we are. So graphing economic data. So single economic variables such as employment, national income, average price can come in two basic forms: cross-sectional data or time series. So cross-sectional data is when you look at things at one period, but you look at many different observations during this period. So for instance, many countries, but all in 2022, for instance. Time series data is when you look at a single a piece of data, but over time. So for instance, in that case, this is time series because looking at, for instance, newsprint, then I have the same exact measurement, which is the newsprint output, but I measure it at different years. So 2010, 2011, 2012, 2013. And by and large, this sort of data is much more complicated to estimate than looking at things at the same moment. Yeah, everything has its challenges, but yeah, usually time series is more difficult because you have to care about so what happened in the past, how it's how the present is new, what is the new information that comes from every observation that was not captured by the past already. So I cannot measure newsprint output at every second and imagine that I have new information. It's just the same thing. So it's, yeah, so you have to look at autoregressive models, moving average models, ARMA models, all these things. So these are more tricky. And there would be one other type, which we would call panel data. Oh, that's quite small. So panel data. So many different observation, cross-sectional, many cross-section over time. So this would be something like looking at, say, a cohort of 100 people and measuring them each year, for instance. So you have a measure of many people and over many years. So that's also even, yeah, it comes with its own set of challenges, of course. Yeah, so one way to look at two variables which are in cross-section is what you call yeah, a scatter diagram. So yeah, I have an example for you of a scatter diagram. Here it is. Just for fun, just to be in the time. So what is this? I'm looking at American states, and we're looking at what's the percentage of fully vaccinated people and what's the percentage of infected people. Yeah. And so what you are looking at is, does vaccine cause people to be less infected? Then if you look at this, then it looks like it does. So that's a neat way to represent your theory. So your claim here is that vaccines cause less people getting sick. I'm just going to leave it on the side there. That's just an example of cross-section data. Yeah, so it's just one over one single period. Yeah, panel is the, so yeah, that's a question in the chat. So yes, panel is a combination of both cross-section and time series. All right, so yeah, here that's a cross-sectional graph of average house prices, but doesn't tell us anything because it's just looking at one variable without any other variable. So you just look at what's happening there. So here, yeah, it looks like there's yeah, house prices are very expensive in British Columbia and Ontario. So yeah, maybe there's a theory to do with that. Yeah, surely there is, but who knows? Graphing conic theories. So I just alluded to a way of doing this. So using a cross-sectional scatter plot. So yeah, one variable x is related to another variable y in such a way that every value of x is there's only one value of y. Then we see that y is a function of x. So we write this mathematically. Oops, we write this y equals f of x. That's usually the way we write this in mathematics for a function. So for each value of x, there's only one value of y. So just to see if you understand what's going on. So is for instance, if you don't care about steel, just look at newsprint. Would you see that this is a function, that the output in 2010 is a function of year for newsprint?
Yes, because it's one value, one x value for every y value.
Yes, exactly. So since I'm interested in newsprint, then every year I have one measure of newsprint. So there's no way I can have, say, two measures of newsprints. So if it were not a function, then it might look like, I don't like this, for instance. Then you would be like, oh yeah, but in 2012, it looks like I have this value and that value. So that's not a function, but if I have only a single value, then yes, this is a function.
It doesn't pass through the vertical line test.
Say that again?
The vertical line test.
Yes, you take a vertical line. Okay, I've never heard of this expression, the vertical line test, but I guess what you're saying is you take a vertical line somewhere and you look whether there are two values or one values. Yeah, that's a good way of checking it. All right. Yeah, so these are all ways of expressing a function. So when W is 0, consumption is 800, and for each extra $1, then wage income will be increased with increased consumption. So here, what you are expressing is the idea that there's this relation between wage and consumption. So for every, and what you're saying is, if I know the wage, I know the consumption, for sure there's only a single value of consumption that I can have. So this is the way you would graph it. So you see that again, if I take a vertical value, there's a single value for my function at every, and then I can express it in a table. So if wage is 0, then I get consumption of 800. If wage is 2,500, then consumption is 2,800. Yeah, what the question?
Yeah, I'm sorry for interrupting. Sir, consumption of what exactly? Like with a wage of 0, what would we consume for $800?
Oh, I can be unemployed, for instance. So if I'm unemployed, I can have maybe I have savings or I have unemployment insurance. This is, I'm not claiming that the only thing I can spend is wage income. If that were the case, then of course I would have 0 consumption. Yes, but yeah, maybe I have savings or yeah. And the thing is, so this you should be able to comfortably go from one place to the other. Yeah, thank you, Mr. Joseph. He gave us the full mathematical expression of this. Oh, yeah, and that's the same, right? 4/5 is 0.8, so yes. So yeah, you could see that, could express it like this. So C equals F of W, if F is wage, and the exact function is 800 plus 0.8. So it's what we call a linear function.
So by the wage, we're talking about the wage of the employee.
Yes, so this would be wage of the employee, and this would be the consumption of the person. I'm not claiming
But-
this is a true theory or anything. I'm just saying this is an example of a function, of a theory that I'm expressing with. My theory is obviously wrong because every theory is wrong. It's just but it's still, it makes sense to imagine that somebody with higher wage will be able to consume more.
Yeah.
Yeah, and as we can, just to go deeper into the economics, since we're still in this graph. So as we look at it, it looks like when you have a wage 0, then you consume more than your wage. But when you have a wage of 10,000, you consume less than your wage. So what does that tell us? In a way, it could tell us something about people's ability to smooth consumption over time. So when they have a very good wage, say a very good year, then they can save. So they can put aside money for rainy days, and then the next year maybe they're unemployed, and then they can tap in this extra savings that they accumulated when they had a good wage to start consuming. That would be an interpretation of this relation. You had a question again? All right, okay, so continuing on, graphing functions. Yeah, so when two variables move together, the variables are positively correlated. When two variables move in the opposite direction, they are negatively correlated. So if I have a graph where the relation look like this and then look like this, so is this one positive or negatively correlated?
Positively correlated.
Yeah, exactly. And this one is negatively correlated. So this would be when it's warm, when there's sun, then it's warm outside, for instance. And this would be when steel goes up, newsprint goes down. But as I've told you, I don't think there is anything there. It's just funny to look at it. So this is just what I said there. So if the two, so this would be also a linear relationship because it's a straight line. It's not curved. If it's curved, then we say it's non-linear. Yeah, so a linear relationship, you can express it just this way. So there's just a coefficient which links the x variable or w variable with the c variable is a constant. Here it's just 0.8. So it means that no matter where you are in the graph, if say wage increases by 1 unit, then consumption increases by 0.8. So since there's always this same relationship wherever you are on the graph, then this is why you get the straight line. Yeah, so if it's not a straight line, it's what we call a nonlinear function. So that would look like this, for instance. So imagine that I have it's perfectly curved. Now I cannot draw a perfectly curved, but like this would be one, or like this would be one, for instance. Yeah, sort of things, nonlinear function. Slope of a straight line. So if x is the variable on the straight line, on the horizontal axis, y is the vertical variable on the vertical axis, then the slope of a straight line is delta y divided by delta x. So note about the whole mathematical approach of this class. So you're never assuming that you know calculus. So calculus is when you take derivatives. So it's something that we learn maybe after high school, or if you're a very advanced student, maybe you learned it in high school. But yeah, but so if you know calculus, then you're going to realize that it's a sort of way to snuggle calculus by the back door, because here we're just taking changes, discrete changes. So say an increase in 1 unit of x, and we are looking at the decrease on 1 unit of a certain amount of units of y. But calculus would just be dy over dx, and it's just saying that we want a small variation in x. But here, so we're never, maybe I'm going to say a few things about calculus, but yeah, mostly we're just going to stick with these discrete changes. So here what we're saying is, if it's a, so we're going to stick with straight line mostly. Yeah, not necessarily, but yeah, most of it. And what is the slope? So the slope is the increase in y following an increase in x. So you can take an increase as large as you want, since it's a delta there, but take it smaller is maybe better. So for instance, if you would take an increase in 1 unit, or here what we're saying is, so if x increases, well, let's write this much smaller, from 4 to 6, y decreases from 5 or 4 to 3, yeah. Yeah, so then we delta x is equals to 2, and delta y equals to -1, and the slope is delta y or delta x. So that's -1 divided by 2. So it's -1/2. And note that if I had taken a smaller change, so for 4 to 5, then I would have gotten the same thing. So 4 to 5, I would have delta x would be 1, but delta y would be 1/2. So I would have gotten the same thing, since the slope is linear. Oh, so that, yeah, everything is written there. I hadn't noticed that. All right. So we almost all our economic theories, at some point we express them this way. So we say, what do I think? I think that if I increase this variable, it's going to cause this decline in this other variable, for instance. All right. Nonlinear functions. So this is the same thing, but what you notice there is that the starting point matters. So if I start at A, and I start from 2 to 3, then what is the change in the vertical axis? It's from 6 to 5. So the slope here is delta P over delta E. So the slope is, oh, it's not written there, so I'm going to write it. Somebody knows what the slope is from A to B?
-1 over 1.
Yes. So we could just say -1. And then what is the slope here? So I can't think this morning, so please somebody compute it for me.
I think it's -1/6.
Yes. Why? Because the change in vertical axis was the same. It's -1 here, -1 here. But here the change in x was not 1 unit, it was 6 units. So what does, so if we want to think about what this means, this could mean, so what are the axes? So this is remaining pollution and expenditure of pollution. Yeah, so what's the theory underlying this? Somebody has an idea?
It's cheaper to start cleaning up pollution, but if you want to get rid of all of it, it becomes more expensive the more pollution you get rid of.
Yeah, exactly. As pollution levels become lower, become very small. So cleaning cleaning an extra unit of pollution becomes more expensive. Yeah, so it's pretty easy to imagine that just say, for instance, yeah, maybe not pollution, but yeah, if you think of cleaning a lake, for instance, then maybe taking away if the big stuff that's in the lake is easy, but then making the water absolutely pure, then it's very, very difficult to do. So yeah, this sort of thing. All right. Increasing marginal cost. So same idea here, but I have a positive slope. So here the slope is so that's
3/1.
Yeah, divided by, and here 10 to 20 divided 10. Yeah, so equals yeah, 3/1, so just 3. And can take another one here, for instance. So that's 500 minus 350. So that's.
So, Professor, what does it mean that the slope differs from some points to other?
So it's expressing the fact that the relation between the variable and the other changes as the level of this variable changes.
I'm sorry, can you repeat that?
Yeah. So that's expressing the fact that, so here, what's the relation? It's annual number of hockey stick produced, and here is the cost of producing cost of production of hockey sticks. So what this expresses is the fact that if I produce a small number of hockey sticks, then each hockey sticks cost me 3, for instance. Yeah, so it's each. Yeah, as I increase my number of hockey sticks, then the cost per hockey sticks is going to increase by 3. But if I already producing a lot of hockey sticks, then the cost per hockey sticks is going to increase much, much more. So maybe that's because I run out of wood, for instance. So yeah, so what this is increasing marginal cost. So marginal cost is, so increase in cost bring an increase in quantity produced. So you could say is cost. So this means, which is to say that. So yeah, cost per extra unit. So per cost per hockey stick, for instance. So yeah, here I was. So this was 150 more, and this was 10. Yeah, 10 again. So was 15. So it's much steeper there. So theory is more hockey sticks. Less wood, so more expensive to make more hockey sticks. So I don't know if that's the case. Maybe now if I can't use wood anymore, I have to use aluminum. Who knows? So I don't know whether that's a real thing or not. I'm not
I have a question.
Yeah.
In these kinds of graphs, is there always a variable that affects the theory, like external variable? Like now you're saying less wood.
Oh, so I have to be expressing something. So what I'm saying is, okay, I think this is perhaps the case or not. Then so I'm just going to see my best guess.
Okay.
So I'm not saying that's true. I'm just saying that that could be a reason. But then to check that, what I would have to do is get some data on wood or get some data on what material is being used in the hockey sticks to confirm or say that, no, it's not related to that. It's something else. All right.
Professor, can I ask a couple questions?
Yeah, go ahead.
The first is like at point Z, it talks about a straight line tangent to the curve. Are we expected to know how to get that tangent or any information about that tangent?
Yeah, we're going to show you how to compute this.
Cool. Okay. And the second is the units for the slope. Do you always refer to that just basically as cost versus sticks or whatever the units on the X and Y graph are?
Yes.
Or okay. You never
So
say like degrees or whatever.
Yeah, that's a great point. So about units, they always exist. But we're less yeah, we care less about them than in other sciences, for instance. So, but it's absolutely true. So with units, you would say it's 3. But that's so. See, that's so annual cost of production. So that would be in thousands of dollars. So that would be $3,000 per year, because that's annual cost of production per. I'm just going per. Yeah, per extra. Yeah, per hockey. Yeah, per 1,000 of sticks. Yeah, so I actually I could just get rid of the 1,000. Yeah. So $3 per year, and per I hope I'm getting this right. So there's always units there. Just we usually don't really look at them all that much. It's not something that we're going to check obsessively, but they are there. So, and sometimes when I draw axes, I like to say this is, say, dollar per unit. This is, because then it matters. For instance, if you think about, is this, if you look at the profit of a firm, so is this a marginal cost? Is this a cost? Is this the total cost of the firm? Or so at some point it can help to look at the units. Yeah. But usually we don't care all that much. Point A is your, point B is your, what's the question there? A is your 1, point B is your 2. No. So this is just yeah, it's not expressing time. This is expressing so probably how did that come about? So it means that sometimes I took measurements of the annual cost of production of hockey sticks and the amount of hockey sticks produced, and maybe this was year 1, this was year 2, this was year 3, this was year 4.
Yeah, that's what I'm asking.
Yeah, and then I put them all on this graph. But obviously this looks like it's made up because I couldn't have exactly 10, 20, 30, 40. The things vary over time. But yeah, this the kind of thing I would have had to. All right. Minimum, maximum. So if you want, yeah, if you have a function, so you need a function for that, and you want an extremum. So an extremum is either a minimum or a maximum. Then what you're looking at is a place where the tangent line. So a tangent line is a straight line that touches your function or your curved line at exactly one point. So here you can zoom in and you can really see for yourself that there's only one crossing there. And then, so this tangent line, if it's equal to 0, or rather not, if it's a maximum or a minimum, or it could also be something else, but so it's going to be the tangent is going to have a slope of 0. If it's a maximum, then the tangent line is going to be positive here, positively sloped, and then on the other side, negatively sloped. So that's how you know you have a maximum. If it was a minimum, then it would look like the opposite. Then you would have negative slope on one side, 0 and positive slope, and your minimum would be here. Yeah. All right. And it's possible to have a tangent line of 0, but not neither a minimum or a maximum. So I can give you, so if you have y equals x3, then in that case, this would look like, I'm drawing using the best of my ability. Yeah, and here you see that you have a straight line of tangent line of 0 here at 0, 0, but still you don't have, you neither have a minimum nor a maximum. So this is calculus in a sense, but we're not going to ask you to compute derivatives. Just looking at it visually, you can know whether you have a maximum or a minimum. All right, and what's the idea there? This is annual level output and profits per year. Yeah, so it looks, what this looks is that if I produce too little, then I don't make enough money. And if I produce too much, also I don't make as much money as I could. And there's a sweet spot that is 2,500. So that's the best I could do as a firm, I guess. The best output to maximize my my profit. All right. So minimum. So here the slope is negative on the left side and positive on the right side. And at the point where the tangent line is has a slope of 0, so that's where you have your minimum. what is this? Speed kilometer per hour and liters of gasoline per 100 kilometers. Oh, so what they're saying there is the most efficient speed is 95. I don't know if I agree with that. Maybe that's the case. I don't. Maybe if you have a big car, then it's best to go at a certain speed with it. But I don't know. I'm not a mechanics or a specialist in it's an older car. Yeah. But actually, I've seen this for a human for walking and running, for instance. So there's an optimal speed for walking and an optimal speed for running. And the thing is, if you try to walk really, really fast, but not run, it's super inefficient. And at the same, saying the same, if you try to go through the motion of running, but going very slowly, it's very inefficient as well. But that's just biology. Final words. Yeah, so we have discussed theories. We have looked at the process of validating theories and explored the ways in which we showed how data works. So that's chapter 2. Yeah. Oh, so we have until 10, right? Yeah, good. So now you're good for lab number for lab number 1 and 2. So let's go ahead. Oh, by the way, there's one lab per chapter, if you hadn't guessed. All right, chapter. Okay, so now we're really getting into macroeconomics. So demand, supply, price. So I guess for most of you, it's the first time you're going to hear about all these things. Or not. Have you taken a economics class before, or a macroeconomics class, or a beginner's class?
Yeah, economics in high school.
Oh yeah, okay. So that's I'm feeling very different. Yeah, it's been I've taken that a very long time ago, but yeah, they talk a bit about supply and demand, but not too much, and a bit about budget and all these things. Yeah, okay. So that's strap on and and let's go try to survive this, because it goes fast, and it takes your sometimes to wrap your mind around all these things. All right, so what we're going to see is what is demand, what is supply, what is the determination of price, and we pay good attention, because you're going to avoid a lot of pitfalls if you really look at this carefully. All right, so quantity demanded is if the price, if I went to, so if all the price in all the stores in Quebec for chicken was $20, for instance, or maybe that's too expensive, maybe $10, then what is the quantity demanded? That would be the amount of chicken that would be bought by consumers. So people who really, really, really like chicken would go there and buy chicken. And some people don't like chicken all that much, and they would just not buy any. And some would go and buy 2 chickens or 3 chickens. That's all part of the quantity demanded. So that's the total amount of consumers that consumers desire to purchase in some time period. So it's in some time period. So it means that it's it's a flow basically. That's if the price was always $20 or $10, then each week, for instance, then this is how many chicken would be bought in Montreal or in Canada, for instance. Yeah, so the actual quantity bought is the actual purchases, and this depend on the, so this depend on the price, and this is what was at the actual price and what was actually bought by people. Yeah, and the quantity demanded, yeah, as I said, is a flow because it's per period, per year, or per week, I don't know. And a stock is something that's just always there. Like it's not something that you purchase every week. It's something that you have and you don't purchase again. Yeah, and the basic hypothesis of microeconomics is that when the price goes up, quantity demanded goes down, and when the price goes down, quantity demanded goes up. Why? Because we assume that people don't like to spend money because they want to use their money to buy other things. So they rather, if chicken becomes $30, then fewer people are going to buy chicken. So is that reasonable? I think it's a reasonable, reasonable thing to say. Might not always be the case. We will see that some in rare instances it might not be the case, but that's mostly true. Ceteris paribus, that's something that, yeah, ceteris paribus. Oh yeah, sorry about this. Somebody knows what ceteris paribus is?
All things equal.
Yes, all else. And why do we need this? We need this because we want to say something non-trivial about the world. So if you say, oh, I think when price go up, quantity demanded go down, but maybe at the same time there was a war between the United States and Canada, so people couldn't get out of their house to buy stuff, for instance. Then who knows why? So maybe people that didn't buy their chicken because it's too expensive, or maybe they didn't want to go in outside because there was a war. I don't know, just making stuff up. But so basically what we're saying is we want to describe the link between one variable and the other. So what you have to say is all the other factors that could influence the thing that you care about. Here is quantity that people demand. We're going to see remain the same. Yeah. So why is that? Well, because so the reason why when the price goes up, people buy less of it, it's because there are several products that can satisfy any given want or need. So for instance, if price, oh, I hadn't realized, but I think my font is exactly the same as, really looks like I'm just writing exactly the same thing as in the slide. Okay, if price of chicken goes up, then I can buy turkey instead. Yes, Ravi?
So if demand goes down, price should also go down?
If demand goes down, price should go down? Is that what you're saying?
Yes.
Yes, that's the case. But so here I'm going to go a bit further along, and always say if quantity demanded. Okay. And by the way, by saying if the quantity demanded goes down, price go down, you're sort of implying, or the way you say your sentence looks like you're saying if people want to buy less of something, it will make the price go down. So here we're sort of assuming the reverse. We're assuming that X is price and Y is quantity demanded, and X causes Y. So we are saying that it's the fact that the price is high which will make people want to buy this. And why do I insist on saying quantity demanded rather than demand? As we're going to say later, demand is going to be an expression of the whole function. So it's the whole set of possible prices and quantity demanded. So this is what we will call the demand. And if you understand this point, so I'm going to talk about it later, don't worry, then it's just going to be much easier for you. Because that's a whole part of what's going on there, is distinguishing the relation that we care about here between price and quantity, and the relation between any other variable and quantity demanded, which would be, for instance, if, I don't know, if there's a disease that affects chicken, then people would like to buy fewer chicken just because they're scared of catching a disease, for instance. All right. So demand schedule. So this is what we mean. So the demand is the relationship or the function. Yeah, maybe that relation. I know the function. Yeah, let's just call it the function. Of price to quantity demand. So remember this. This is really important. Okay, so it means that the demand is this whole thing. The demand is the graph itself, all right? And then if I look at a specific point on the graph, I say, for instance, I look at X, what is the point X? The point X expresses the fact that if the price is $80, then the quantity demanded is 50. So price, quantity demanded, but this whole table there, or this whole graph there, is what we call the demand curve for Apple. All right. How do companies calculate the quantity demanded? Well, here no single company can do that, because that's just what we would use is statistics at the national level, for instance. You would have to add up all the quantities that were bought in Canada, for instance. It's at the intersection of the price curve and the cost curve. Not sure what. So here we only have one curve, right? It's just the demand curve. So you don't have intersections already. It's just one curve. It's just a bunch of a link between price and quantity demanded, and this is what we call demand. So this is called the demand. Right. So
I have a question.
yeah.
For instance, let's say someone wants to start a business He doesn't know the quantity demanded number. So what does he base, like how does he know how many products he's gonna sell?
I don't know. I can never start a business.
I'm just asking.
So you have to do a market discovery or a sort of yeah, so it's a market study to know what you expect, how much you expect people to want to buy, and you can always make mistakes. So it's like anything. If I make a movie and how many people are going to watch it, well, I hope as many as possible, but maybe it's a flop for whatever reason. So it's you cannot predict that. This is a conceptual way of looking at it, or you would say it's after the fact, because after the fact, if someday you had a high price and a low quantity, or someday you had a low quantity and a high yeah, low quantity, high price, or low price and high quantity, then you could build such a curve. Now, let me go even further than that and say the following. So this is just going beyond this class because we just started, but still, since we're talking about this, economists know more or less what's going on here, but we have really little idea what's going on there and there. Why can we say that? Well, because it never, so if you look at, so imagine this is, yeah, 1,000 of Bushnell and price of apple. So to know what is the shape of this curve, then we would have to observe years in which you have this amount of apple, this price, this amount of apple, this price, this amount of apple, and this price. Do you observe them? No, because most of the time the industry is pretty stable. We have certain number of apples sold. You would have to observe like a time where there was I don't know, snow, and that, so you couldn't get enough apple, and then you could maybe observe this and the price there. But most of the time, everything goes on around the equilibrium there. I'm just introducing terms. But basically, from a scientific perspective, we have very little idea of what would happen if there was a production of 120, because it never happens. So yeah, can I know this curve for sure? No, I cannot. Computing that is a huge challenge for economists. And yeah, for a single firm, you don't know, you just hope for the best. You say, I love Apple, so I'm going to start an Apple company and make cider and hope I make a profit. But you have to be optimistic. All right. Now, so this is the demand. This is the demand, and this is ceteris paribus. All right. This is assuming that nothing else is different except the price level and the quantity bought. That's the only thing that changes in this world. Now, can something else change? Of course, many other factors change. And what would that mean for this relation? Well, it's going to shift it up or down or right or left, because it's going to, so if you assume, for instance, that, yeah, all of a sudden, oranges disappear, okay? So if oranges disappear, then a certain number of people that would have bought oranges in the breakfast, now they think, oh, I really would have a fruit in the breakfast, but oranges are no longer around. So let me substitute my orange for an apple in the morning. What would happen to this demand curve? Would it shift up or down? So right or left? Somebody has an idea?
Maybe it will shift right.
Yes, exactly.
Right,
It Yeah, it's perfect. It means that if the price is $40 per bushel, yeah, it's the first time I see this word. So before the disappearance of oranges, I would have like 80 or something, or 50, I would have had 80. But now for the same price, since more people want apples, then the demand is going to shift right. But you see that every point is going to shift right by some amount, because if the price was this, but then oranges disappear, still people would like more apples. So you're going to have a shift in the demand. That's what we call. So if you have a change in price, then you have a movement along this line, and you have a change in some other variable that's not price or quantity, then you have a shift in the line, right? So this is what we're going to say here. So a change in a variable that's not the price will shift the demand curve to a new position. So it can be, so let me just say, so for instance, if people are, if income increases, so shift up or down. Somebody has an idea?
Right.
Shift right.
Yeah, shift right. And by the way, so yeah, I guess it's good conceptually to think it's shift right because more people want to buy, but there's really isn't any difference between a shift right and a shift up, because anyways, this shape, this exact shape might not be represent the exact reality. So so yeah.
What about the price of apples? Does it go up as well?
So it would be this shift like this, for instance. What about the price of apple?
Yeah, of apples. For example, if there's more quantity demanded, does the price of apples go up?
So what you're saying is if there's a larger quantity demanded, then it's because the price of apple went down. So here, this is a movement on the curve, all right? So yeah. So change in price or quantity demanded, movement on the curve. And if you have a change in something else, you have a movement of the curve. So the whole curve is going to shift, say, right and up or left and down, for instance, right? So let me just copy this real quick. Okay, so we can have this as reference. So if price of if the price of oranges goes up, does the curve shift right or shift left or up or down?
Shifts to up.
Yeah, probably up, but not sure. Maybe. Because I'm going to, so here I said other goods and it could be anything. So oranges, yeah, probably. But if you think about the change in price in trying to think of something you eat when you eat apples. Like okay, ice cream, for instance. So if people really like to eat ice cream with their apple, and the price of ice cream goes up, then is the demand for apple going to go up or go down?
Excuse me, by other goods, do you mean the raw materials?
So I'm saying, so maybe apple is not the best example, but think of like sugar and tea, for instance, or coffee. Then since you always use your sugar with your coffee, then if the price of sugar goes up, then it makes you less want to get coffee, because you know you can't put as sugar in your coffee as much as you would like, because the sugar is more expensive. So in that case, you would have the price of sugar would decrease the demand for coffee. But if you think about coffee and tea, then if you're like, oh, in the morning, I don't really care all that much if I take a coffee or a tea. So then in that case, if the price of tea goes up, then you're going to say, oh, I'm going to shift to coffee. So then for coffee will go up. So here it depends on whether this good, say here orange, is a substitute or a complement to, so I'm just going to say depend. If substitutes or complements. And so don't worry, we're going to go back and discuss this more in detail. All right, consumer's taste. So that's quite obvious. If people decide that they really like apples at some point, then of course they're going to want to buy more of it. So
Quite robust.
yeah. Population, if more population. Then shift where?
Wouldn't this be changed on
Right.
the curve because the quantity demanded will increase?
Yes, so shift. Right. And changes in weather. So that's
Shift up or down. No?
yeah, so that in that case, so here you really have to think clearly about what we're talking about. Here, what we're talking about is the attitude of consumers. So you could think, oh, if there's good weather or bad weather, it's going to cost more or less to produce apples. That's totally different. That's on the production side, where we haven't talked about that yet. Here, it's really a description of behavior by consumers. So all that you could see is something like, I don't know, if people like eating apples outside, then bad weather shifts the demand curve left down. And good weather would shift it right. So so what you're describing here is people's behavior.
Excuse me.
Yeah.
For population, I was asking because the population, for example, it increased. Didn't that mean that the quantity demanded increased? So then it should be a change on the curve rather than movement of the curve.
So no. It really is. So imagine that you multiply the population by 10. How would that change? But everything stays the same. So how would that change this graph? Well, you could just add a zero there. So because like at the price of $40, then 85 Bushnell per year were bought. So then you have 10 times more people. So it's 10 times 85, so 850. So this would shift like 10 times to the right.
Oh, okay. Okay.
Excuse me, sir.
Yeah, go ahead.
So just to reconfirm, all the changes in the variables except for the price and the quantity demanded.
Yeah.
Remove the curve to a new position, but then if it's either price or quantity demanded, then it will change the curve shape itself.
No, it's just that you would go from this point to that point to that point, for instance. So you would move on the curve. So you would it's the curve describes this thing happening. So if you're saying what happens if the price of Apple, if the price was 100 and it decreases to 80. So, okay, well, you just look at your curve and you know exactly. So it means that the quantity demanded go from, say, 40 to 45. So you're just moving along this curve. You're just looking at what you're describing.
Oh, okay. So it's the starting point.
So the shape doesn't change. Yeah, it's just that's this relation you're describing. Yeah.
Thank you, sir.
All right. Oh, and by the way, so one thing. So some of you might be wondering, but it looks strange because I'm used to having I'm used to having like something like this with y and x here, and usually x influences y, right? And here it looks like you have, as I said, you have some price, and that price will dictate how many people would want to buy it. So it looks like it's flipped, right? So if you think it looks like it's flipped and it shouldn't, well, you're not alone. It's normal to think that. But so this is due to, I think it's due to Alfred Marshall, who was a great economist at the beginning of the century. And he really decided that analyzing things this way, putting quantity on the horizontal axis and price on the vertical axis, made analysis easier, as you're going to see later. But it doesn't mean that quantity causes price, all right? So it doesn't, if we put quantity on the horizontal axis and price on the vertical axis, still it makes more sense to think that quantity will influence the quantity but, and price will influence the quantity but, and not the reverse. Okay. Right. So what is this? Oh yeah, so that's expressing what it means to have a shift in the demand curve. So for instance, if the annual income was $50, so this would be the relation between quantity of Apple and demanded and the price. And then if we make the person more rich by increasing the annual income to 60,000, then for every possible quantity, you would have, for every possible price, you would have a greater quantity but, because the person has more money that the person can spend on more apples, for instance. And so it looks like it's shifting right. I think it's a good way to think about it. But mathematically, it doesn't really make any big difference if you think it's shifting right or it's shifting up. So here it really looks like I have just copy pasted this curve right, because the shape really looks like just a translation. But in real life, it's economics. So nobody ever know perfectly what the shape of this curve is. So really it's just on average, you would see that the curve shifts that way, but the exact shape, who knows? Yeah. Okay. Yeah, so a rightward shift, it means an increase in demand, and a leftward shift means an decrease in demand. A shift left and up on the same curve is a decrease in the quantity demanded, and a shift down and right, but on the same curve, is an increase in the quantity demanded and a decrease in price. So that's the big difference between demand and quantity demanded. So this is something that you just have to get get used to saying. It's a way to express things. All right. Oh yeah, and
I'm sorry. I'm so sorry for interrupting, but can you just repeat what you said? Like the difference between quantity demanded and like demand?
Yes. So exactly. So this, if we have if something else that is not price or quantity changes, then you have a shift in demand. So like a rightward shift or leftward shift from the demand that is D0, which is this whole curve, to D1 with D2. But then the other situation is a shift along the demand curve or on the demand curve, which would be a change in price and then causing a change in the quantity demanded, for instance. Okay, yes. I think it's a bit confusing to present it this way, but yeah, so that's basically what I've been saying for the last 5-10 minutes. Change in demand refers to a shift of the entire curve. So it's from D0 to D1. And the shift on the demand curve would be a shift from P0 Q1 to P2 Q2, for instance. So this would be a shift on the demand curve. So this, you would just have D1, the demand curve 1, and you would have a shift along this. So that would be a change in quantity demanded along the demand curve. Questions again on this, or can I go forward? All right, so if there's any anything that's confusing to you, so just stop me again and I can explain it again. All right, so now we're going to supply.
It's 10 o'clock.
Oh, it's 10 o'clock. Okay, all right. Just look at it. So yeah, you're here. All right, so yeah, I'm going to stick around if you have questions or comments. Otherwise, class dismissed.
Have a nice day. Thank you.
Have a nice day.
Okay, have a good day.
Thank you, sir. Have a good day.
Sir, have a good day.
Thank you.
Thank you. Have a good day.
Thank you.
Thanks. Have a good day.
Thank you, sir.
David Mansour. And Mr. Mansour, you raised your hand or not?
Thank you very much. Goodbye.
Goodbye. Oh, 2 people have raised their hands. So whoever wants to say something, go ahead.
Yeah, I'm not sure what's happening with David, but so I just wanted to ask for another explanation about like what is the movement along a given demand curve. So is it just like, oh, so it's like it's kind of like domain. Is it correct for me to think of it as like the domain thing, where like there's a curve, and when we shift the quantity demanded, then we shift like the area, like the sections of that curve that shows up on the graph, or is it something else.
All right, so let's go ahead and draw some stuff. I'll go back, take some space. Okay, I have some space here. Right. So this is quantity, and this is the price. And this is demand. Maybe it looks like. All right, so this is what it looks like if nothing else changes in the world except quantity. Oh yeah, quantity demanded and price. All right, if tastes stay the same, if income stays the same, price of other goods stays the same, and then I were to ask you, but what if the market price goes from, say, so this is 10, for instance, to everything smaller. All right.
Sir, can you hear me?
Yeah. And imagine this is 8 and 6 and 4, maybe 4. All right. So if nothing changes, except maybe the market price, then this is the relation that you would observe between the market price and the quantity demanded. So you would say if the price is 12, then the quantity is going to be 4. And if the price goes down to 10, then the quantity is going to go up from 4 to 8, right? And this is what happens if nothing changes in the world. Now, if something changes, so for instance, everybody has a better income, or so Trudeau government gives people money to spend in the economy. So then what this means is that the demand is going to shift this way. Let's use another color. So let's use green, for instance. So demand, this would be demand 1. And then this would be another demand 2, for instance. Okay, so demand 2 is another relation between price and quantity, where some other factor that you don't see, like people's income or people's tastes, will change this relation. So it means that before for price of 12, people would have bought 4. And now for a price of 12, you see that people would buy maybe 12 units. Does that make sense?
Yeah, that absolutely makes sense. It's just that the change in price, I guess, change that is So I guess that this happens with all the changes that are in variables that is not priced. But if it's priced, then like the curve will shift. The starting point will change, like you said before.
Oh yeah, so you could say, oh, I start at a situation when the price is 10, and I look at what happens if the price goes down to, I don't know, to 4. So then I get a quantity of lot.
I see.
So that would be a quantity of 8, 16, like 20 something. Yeah. Yeah, so but I keep moving around this curve. Right.
Oh, okay, just moving. So can you go to the last slide that we had, the last slide that we stopped on, the one before the supply?
Yeah, that one. Yeah.
Yeah, so wouldn't it make more sense for like the second phrase, like a change in quantity demanded?
First one.
Would it like, I guess I thought that would be a change in price refers to movement along a given demand curve.
Yes, yeah. So something I should have added. So this and price. So the two change together. Yes.
They have to change together. Okay.
Yeah.
Okay, I see. Thank you so much. That cleared up.
My pleasure. Yeah.
Hello, sir. Can you hear me?
Yes. Yes.
I just have a quick question about the packages of the MyLabs, the Pearson MyLab and Mastering.
Yeah.
What's the difference between them? Because there's one that's for like 50 and one for 95. When I want to register.
I have no clue.
I can help with that. It's like one has the e-text, the textbook included, and the other doesn't have it. So if you already have the textbook, yeah.
So one just gives me access to the exercises and everything, but the other one gives me the book as well?
Yeah, just the book. The book
all right,
is
thank you.
$50. Have a good day, sir. Goodbye.
Okay, thank you. Have a nice day, everybody. Bye.
Have a good day, sir.